Hi, I'm Tim Brown. I'm the CISO for SolarWinds. Today I want to take a few minutes and talk to you about our next generation build system. Our next generation build system was developed by SolarWinds architects and industry leaders across the world. We've also given back a lot of this to open source. So what makes up a good build system? First we look at a number of different tenets. The first tenet is to make sure the system has been built on ephemeral operations. What does ephemeral mean? Ephemeral means that it gets built every time. It's not static. It doesn't live for a long time. Why that's so important is that ephemeral systems very difficult to attack, very difficult to see because, again, they're built every time you need them, so they're just built up. And also, when we look at ephemeral, what goes along with that is built into code. So everything done in code, and you treat your build environment like you treat source code. So you check in the build scripts, you check out those build scripts, you run those build scripts that then create the environment where a build will be done. So ephemeral, one of the key issues or key starting points. Products need to be built deterministically. Products need to be built in parallel, and then you need to record every build step. So we talked a little bit about ephemeral, but when we talk about building in deterministic, why is deterministic so hard and so important? Deterministic means that when you build something, the next time you build from the same source code, it will be binarily compatible before, so it will equal. So that's one of the keys, is to make multiple builds equal what the prior build was. You say, well, it's the same source code. Why would it matter? Why should it change? The problem is time. So time changes, and that time change results in a build that has a different binary signature than a build that was done a second ago or a minute ago. So when we look at deterministic, we have to come up and figure out ways that we can make time be irrelevant, so that when we do build, say, always the same from the same source code. Very hard to do again. So this is some of the things that we submitted back to open source. The next step, you'll see why that was so important in our overall build model. Build in parallel. Now, in this model, we do multiple builds with multiple pipelines, and then we compare the results. So hence, comparing the results means that they're built at different times. Time is not a problem if you're deterministic. With deterministic builds, you can do binary comparables to each one of the builds. So that's why deterministic is so important. So when we look at building in parallel, why build multiple pipelines? Why build multiple times? So we do a lot when we do a build. So we do different types of testing when we do a build. So we do validation testing, takes a period of time. We do security testing, takes a period of time. We do developer builds, which need to be fast so that developers can make code changes, click a button, do a build quickly. So from a practical perspective, 3 different pipelines say they can run independently, they can run at separate times, but you still get the comparing at the end of them. So why that is so important from a security perspective is that not any one person has access to all 3 builds. So if you were going to affect our build, you would need to get collusion amongst multiple people in order to have them compare at the end. So it's an extra safeguard we put into place to make sure that the build environment doesn't get corrupted. So you build a security pipeline, you build a validation pipeline, you build a developer pipeline, you compare the results. As long as the results match, we ship. If the results don't match, we go back and investigate and determine, hey, what went wrong? But we don't ship until all of those compare. So very important model. The picture here is a little cluttered, but when you think about what we have provided, what we use from an open source perspective, how we do these things, there's a lot of devils in the detail. And there's a full white paper that goes through the details of each of these. So if you're interested, please refer to the white paper. The final tenet here is recording every step. And why is it so important to record every step? It's important to record every step so that you have a record to go back to, a record that can't be tainted, a record that can't be modified. So in our case, we put everything into a data store. We use tecton chains. We put it into a common database. And with that in a common database, we can then look back and say, oh, this build failed on this reason. Oh, this build failed this step. So we have a record that we can trust in the future to be able to go back to the builds and see, what changed or what failed at that point in time. So when we look at the build system, it's just one of the components we have for really secure by design. And when we look at secure by design, it's about our environment, it's about helping the industry, it's about helping our customers. So with secure by design, we're giving back to the community through open source. We're moving the needle forward and helping others move the needle forward. We're giving back to the community in the form of participating in things like CISO's initiatives for SBOMs and CISO's initiatives for, really helping us to measure the risk of vendors and helping with the whole community of making more resilient products. So absolutely leading by example as we move forward, big part of secure by design. So thank you. If you'd like more information on the build system in general, there's a great white paper that will be listed here.